ini agak berhenti itu cuma half dia cuma ditahan sebenarnya bukan headshot ini apa tuh
Next week we will have a midterm, and we will be cover chapter 8, 9, 10. Okay. And since PhD students they are going to present the paper I provide to them at the beginning of the semester, so they don't need to take the midterm and final. And for master students, okay, you do need to take the midterm and the final. Otherwise, there is no way I can grade your grade. So bring your laptop, okay, next Wednesday, and write all your answer and make copy from the SPS Outlook to your Word file and save it. Remember, don't forget your name and your student ID number. Okay, and so when the exam is the end of the class, okay, at 9 o'clock next Wednesday night, okay, send your file to my email, okay, and my email, did you know my email address?
It's on the
Yeah. 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 Everyone has the same. Okay, so this is my email address. Send me your file, okay, for the midterm and mail it to me at the end of class next week. Okay, and this week we are going to talk about the inference about population. So we have one population and two population. So in many cases, people are interested in balance And the variance can determine the quality of your process. Okay. The lower the variety, the better the process. Okay. So the chi-square distribution, we chapter 7, 8, or 9, or 10, we talk about the Z distribution and the T distribution. This chapter we cover a new distribution we call chi-square distribution. And the chi-square distribution applies in many areas. Okay, chapter 12 we also use chi-square distribution. So next week will be, today is 6, so next week will be 13 will be for your midterm, and the 20th we will cover chapter 12. Chapter 12 we use chi-square distribution. And the chi-square distribution comes from normal distribution. And the summary distribution of this one follow chi-square distribution. This is the chi-square distribution. And for chi-square distribution, you need to know the degree of freedom. The degree of freedom is -1. So the larger the degree of freedom is similar to normal distribution. The lower the degree of freedom is like an exponential distribution. So for T distribution or Z distribution, in the middle is 0, and we have a positive or negative. But in the chi-square distribution, you can see this formula. Everything is positive. Everything is positive, so there is no negative. So from 0 to larger value. Okay. So this is a chi-square distribution. And so we are interested in a complex interval for about the population variance. Okay. And this is the chi-square value. Okay. If we are interested in 95 complex interval for the population variance, okay, that means we have a 2.5% and 2.5% on either side. Okay. And this means there are 2.5% on the right, and this value is chi-square with the value, and this means on the left hand side is 2.5%. On the right hand side there are 97.5%. So some students just confused. Okay. If you look at the table, this value will be smaller. This value will be bigger. Okay. And the complex interval, the chi-square value between this range. So there are 95%. So this means outside there are 5%. So either side there are 2.5%. So based on the formula, okay, and since chi-square equal this one, and we are interested in the sigma square. Sigma square. So you take this to the left hand side, this to the right hand side, and this one if you derive to either side. Okay. So sigma will larger than. And if you take a square, okay, you got a sigma square, and everything's take a square. And since this value is smaller, just very good. This one is smaller, so this value will be bigger. So this is upper bound for variance complex interval. And usually we are interested in the population standard deviation. So sigma, the complex interval for sigma is equal this formula. You just take the square root of each side. So this is the we are interested in the complex interval we are interested in. This is a thermostat, like the temperature device. Okay. Suppose in one particular room the temperature is 68 Fahrenheit, and if one company they produce this device they call thermostat, and the same product they're supposed to measure the same degree, same temperature. And for 10 devices, if you put 10 of this device in the room, in this room, and you will get different value. Okay, so we are interested in 95% confidence interval of the population standard variance. Okay. And I suggest you study the population standard deviation, not the variance. Okay. Because variance, the unit of variance, it doesn't make sense. So we are interested in the population standard deviation. You just take a square root, you will get the population standard deviation. Okay, so the degree of freedom is 9 in this case because they are 10. So 10 minus 1 is 9. Okay. And we are interested in 95%. So 95% between, okay, this is 2.7. 0.975 upper, okay, in upper tail. So the chi-square value will be 2.7. The other one will be 2.5 in area in upper tail. So it will be 19.023. So this is the lower bound for chi-square, 2.7, based on this value. Okay. And the degree of freedom is 9. The upper tail area is 97.5%. So the chi-square value will be 2.7. And the upper tail area is 2.5%. Okay, so the chi-square value will be 90.023. When alpha is 5%, that means we have a 95 confidence interval. So the lower bound for chi-square, this is chi-square, and the chi-square equal this formula. And the upper bound is 19.023. So the chi-square value equal this formula. And we are interested in the sigma square. Sigma square. And in order to get the confidence interval for sigma square, we need to know the sample variance. And the n we know, in this case, n is equal 10. And the sample variance equal this formula, you can easily get from the software. So the sample variance is 0.70. So if you put it in the formula, you got the confidence interval for chi-square. And no, this is a sigma square. So the variance, the population variance confidence interval, 95% confidence interval is in this range. And on the other hand, you can conduct a hypothesis test. Maybe it's lower tail test, sigma square less than sigma 0 square. And sigma 0 square can be any number. Okay. And the two-tail test is not equal. And this is upper tail test. So the critical value for lower tail test, whenever the chi-square value less than this value. So for two-tail test, whenever chi-square value less than 1 minus alpha, or larger than alpha. This is not correct. It should be alpha divided by 2. Okay, this is not 1 tail. This is 2 tail. So this should be divided by 2. This should be divided by 2. For upper tail test, whenever chi-square larger than alpha, then we reject. And whenever p-value, no matter is 1 tail or 2 tail, whenever p-value less than alpha, we reject no hypothesis. So we have a confidence interval, we have a hypothesis test. So for hypothesis test, the sigma 0 square is the value you are interested in. The test statistic for chi-square equal this formula. So this previous example, they talk about the BIOS Digest company that produce thermostat. Okay, they are interested in whether the variance and they say the variance will be 0.5 or less. So if the whole company, their thermostat, their variance is less than 0.5, it's okay. So this we call this is acceptable. So the hypothesis say if you are the buyer, you want to prove their quality is not good. So you say, okay, their variance is not good, so the variance is larger than 0.5. 0.5 is what I call so-called who designed this number? Okay, buyer designed this number. So this number, and so that's why talking about say that if you are a buyer, you think that everything their product is not good, their product quality is not good. So you won't prove the variance, their variance is larger than 0.5. And this is one tail test. So this one tail test is this case. Whenever chi-square larger than chi-square alpha, then you reject, or your p-value less than alpha, we reject the non-hypothesis. So in this case, you are interested in reject the non-hypothesis. That means if the atomic hypothesis is correct, you will return the product to the manufacturer, okay, to the seller. And you randomly select 10 devices from this manufacturer, and you measure the temperature in this house. Okay, they got different measurement. And the degree of freedom is 9, and the alpha in this case is 10%. 10%. 10% is, if you're a buyer, you prefer alpha is 10% or 1% or 5%. If you're a buyer. Degree of freedom 9, 10% is here. Okay. 10% is here. 14. 1%, 5% is 16. 1% is 21. Which one will be easier to reject? For larger alpha, it's easier to reject non-hypothesis. So who will set the alpha equal 10%? Because the larger number is not easier to reject. So if it seems to buyer set up the alpha equal 10%. 10%. If you are manufacturer, you prefer they use 1%, so that they have a bigger alpha, so it's not easier to reject. When alpha is smaller, the chi-square value will be bigger, so it won't be easier to reject. So it seems to, and this is the bargain power is in seller's hand. So seller has more authority or power to request smaller larger alpha. So you got a smaller value of a chi-square. If you are manufacturer or seller, you prefer 1%. So it's not easy to reject non-hypothesis. Okay. In this case, seller has more bargain power. So they want to, because there are so many manufacturers, they want to sell the bigger wholesale, like a Walmart, like a Costco, like big supermarket, and the buyer of like this kind of grocery store, they have a more bargain power. So manufacturer, they just listen to this buyer. And in this case, the buyer they ask 10%. So the chi-square value is small, so it's easier to reject. So in this case, degree of freedom is 9, and it's one deal test. So 10%. The chi-square value is 14. If the chi-square value is 1%, it's 21. It's not easier to reject among classes. So the critical value is 14 for alpha is 10%. So this, it seems to, the bargain power is in buyer's hand. If buyer prefer 1%, it will be, the chi-square value will be 21. Then it's not easy to reject. And in this case, the formula, the chi-square value equal this value. And the sigma 0 square is 0.5 because the problem is 0.5. Because 0.5 is the both sides they negotiate. This is the value they negotiate. So the variance is 0.5. So you can put 0.5 here. The sample variance you should get from the data. In this case, the sample variance is 0.7. So the chi-square value in this case is 12. Okay, 12.6 is here. Now, so it's not bigger or greater than 14.684. So now we check. That means since this manufacturer, their variance, sample variance is smaller, so that's why the chi-square value is smaller. So the null hypothesis is not rejected. That means the buyer cannot reject the manufacturer or seller's product. So they need to pay the money. Okay, and so the manufacturer can sell the product to the seller because the null hypothesis is not rejected. You got it? And the p-value in this case, you can see the p-value since it's 12. 12 is here. So the p-value is larger than 10%. So since p-value is, whenever p-value less than alpha, we reject the non-hypothesis. But in this case, the chi-square value is 12. So the p-value is, you can see this is like a Europe. This is like the North America. So this is Atlantic Ocean. Big, huge. Okay, between there are 80% in the middle. Okay, so the chi-square table they don't show 20%, 30%, 40%. They just show on the left hand side and the right hand side, and there is a big gap between both sides. Okay. And in this case, the p-value is larger than 10%, so the conclusion is not rejected. And since your chi-square value is 12.6 and the table value is 14.684, the 14.684 is depend on the degree of freedom and the chi-square value and the alpha value. Okay, and based on the critical value point of view, and since chi-square value is 12.6, it's less than table value, so not rejected. How about the p-value? The p-value we can see from the table. I say the p-value following the Atlantic Ocean, okay, is larger than 10%, so it's not rejected. So the conclusion will be the same. So you can apply the population variance for one company or two companies. So the first section is talk about one population variance. And this is the problem come from the textbook. Question number 11. So the data are already open. This one. There are 51 samples. This means there are 51 undergraduate students. They take GMAT and this is their score. The question number 8 asks you compute the mean variance and the standard deviation of this 41 observation. So analyze statistic, discrete. Mean standard deviation variance. The answer is the mean is 569.47. The maximum is 794. The minimum is 329. And the standard deviation is 129.047. The variance is this much. Okay. Usually we are interested in the standard deviation, not variance. Okay, this is the question number 8. Question number B. Hypothesis test. Develop hypothesis test. Population variance is 14.146. Okay, and the one test. The question. Whether the default. So this is their test. So the variance equal this one. Okay. Our time about say. And the classical value in this case. The software only provide this table for you, and then for this formula, you got to do it by yourself. The reason they use 51 because they won't get 50. The sample variance is here. .94, okay. Divided by let's see. This is huge because this is larger than 1 and this is 50. It's big. And the particular freedom of 50 check table. Question number is 5%. 5%.
Finance.
5%. If your freedom is 50, the table value will be 71. 71. And this side 97.5. If your freedom is 50 equal 32. 32. In this case, how much did you get? 50 multiplied by this. How much? 1 point. How much? 1.16655 divided by 146.